is part 2 of the Hess's law problems. You can check out my part 1 for an easier Hess's law problem, and here we will tackle the one that is a little bit harder. We can see that we are given 3 equations or 3 steps, and we have to use Hess's law to calculate delta H for the reaction that is shown below. So this reaction we need to find delta H for. We don't know it. From my previous video, I gave you a trick. I said we're supposed to look at each equation and find a molecule that equation has in common with the overall reaction, but that other equations here do not have. If we look at equation 1 and 2 is not a part of my overall equation, O2 is also not a part of my overall equation, and NO, unfortunately, this part has. So number 1 is a little tricky, and I'm going to go ahead and leave it alone for later to make it easier for myself. I'm going to go ahead and go to number 2. In number 2, we can notice there is a unique molecule. The molecule that the second equation has is NO2. We can see that we have NO2 in the equation that we're looking for, and we can see that none of the other equations, 1 or 3, have it. Let me go ahead and number them since I keep on using 1, 2, 3. Okay, now that we can see that NO2 is a unique molecule, we will notice that, first of all, here NO2 is a product, and here it is a reactant. That means I have to invert my equation. Let's go ahead and invert it first. I'm going to get 2 NO2 gas goes to 2 NO gas plus O2 gas. Another thing that you will notice is that there is no number in front of NO2, which means it has a coefficient of 1, but this one has a coefficient of 2. That is no good, so we have to multiply this equation by 1/2 to get, and we will get NO2 just like we want it to be, goes to NO. Each coefficient gets multiplied by 1/2, NO gas, plus 1/2 O2 gas. Now, in terms of my delta H, as you can read the rules I wrote above, if we invert the equation, we need to change the sign for delta H. So let's change the sign to plus because it is minus here. And if we multiply equation by number, we multiply delta H by that number. So we're going to go ahead and multiply our delta H by 1/2. So we will get 13.1 kilojoules. Great. This second equation is done, and let's look at the third one. Is there a molecule that it has that is unique? Well, if we look at this one, we have N2O, and we have N2O in the overall equation that we're looking for, and none of the other equations have N2O, so we can use it. Now, what happened to N2O? It is on the correct side, both of them on the reactant side, but again, it has a 2 in front of it and this one does not, which means we need to multiply the whole equation by 1/2 or divide by 2, whichever way you want to put it, and we will get N2O gas goes to N2 gas plus O2 gas. Perfect. The delta H for this one will be we do not change the sign since we did not invert it, so minus 163.2 kilojoules, but because we multiplied it by 1/2, we need to multiply this delta H by 1/2 also. Let's call it delta H1, delta H2. Okay, now that we have dealt with the two lower equations that were easier to deal with because they had a unique molecule, we can get to the third one. Perhaps it will be easiest to first sum them up to see what they will give me overall. So right now, my equation is NO2 gas plus N2O gas goes to NO gas plus N2 gas plus O2 gas. Okay, comparing this equation to the overall reaction, I see that NO2 is taken care of, it's here, and 2O is also taken care of, so the left side is perfect. But on the right side, instead of 3 NO, I have only 1 NO, and I also have N2 and O2, which I do not need here. I need to get rid of it. Well, if I look at my equation 1, I see, oh, well, N2 and O2 will be able to cancel since these are on the reactant side, and in this equation, they're on the product side. And then 2 NO here will add up with 1 NO here to give me 3 NO, which means I do not even need to change step 1 of the equation. So I'm going to go ahead and write it. I'm going to say N2 gas plus O2 gas goes to 2 NO gas, and its delta H will be, let's delta H3, this same. I did not change it because I did nothing, absolutely nothing to that equation. Now let's see if it works. When we add these two equations, we can see that N2 here is on the reactant side and here it's on the product side. Cancels. O2 is on the reactant side and here it's on the product side. Cancels. And NO plus 2 NO will give me 3 NO. So my overall equation becomes NO2 gas plus N2O gas goes to 3 NO. We had 2 here, 1 here. That gives me 3 NO. To find the delta H for this reaction, what we need to do is simply add delta H1 with delta H2 with delta H3. When we add all of the delta H's that we have calculated, we will be able to get the delta H for the reaction that you're looking for. This is Maya from Transformation Tutoring. Please subscribe, like, ask questions, and I will see you in my next chemistry video.